I'm curious. I am curious. Curious
by nature.
Welcome to Curious by Nature. I'm Jessica Johnson from Newswise. Are you paying attention? There is a series of complex events that influence your brain's ability to focus, based largely on how curious you are about the problem. From animal behavior to probability analysis, the emotional component to brain activity is clear. The more uncertainty, the stronger the drive to work it out. For a deeper understanding of the inner workings of the mind, we are joined today by a researcher that has made curiosity the focus of her work at Columbia University. Dr. Gottlieb, welcome. Please introduce yourself.
My name is Jacqueline Gottlieb. I'm professor of neuroscience at Columbia University in the Zuckerman Institute and the Department of Neuroscience.
And can you tell me more about your work?
Yeah, so my work involves the neural mechanisms of cognition and decision making. And I study them in humans and also in animals.
Mm-hmm. And recently you've had publication about curiosity. And our podcast is called Curious by Nature because we interview people in all different fields with all different topics who are researching in depth and spend their whole lives focused on, very specific things sometimes. And so I was really interested to talk with you and curious to talk about curiosity. So please tell me more about that.
Yeah, so curiosity is, I think of it as the new frontier in neuroscience and cognitive science research. And it's a topic that, as you can see, it's very intuitive and very obvious that people are curious and animals are curious. And yet it's a topic that somehow neuroscience and psychology have neglected for these past centuries that we've been doing cognitive science research. And I had a student a few years ago who was interviewing for a PhD program. And he said, I think this is an interesting topic, but somehow it's not something you can say in polite society when you talk to neuroscientists. Somehow it wasn't perceived as rigorous or as interesting. And I think that the reason is that there are deep sociological reasons for this in the way that our fields evolve. So we all take a reductionist approach to brain and behavior, and we simplify things in order to be able to study them. And there have been two kinds of simplifications historically in our fields. So there's been one half of neuroscientists and psychologists, roughly. It can be loosely defined as cognitivists. So in other words, they think about cognitive processes. So that's mainly attention and memory, how they work, how people can perform them, things like how quickly can you switch your attention, how long can you sustain attention, how precisely can you, how many things can you remember, and so on. So the limits of cognitive performance and then the neural substrates of that. And then the other half of the field thinks about motivation and decision-making and motivation. And that half of the field was really strongly shaped by behaviorism, by B.F. Skinner earlier in the 1900s, who said, all this talk about cognitive stuff, it just feels a bit soft and loosey-goosey, and these internal processes, who knows what you're measuring, and I don't know if I can trust it. But one thing I can trust is behavior. It's the behavior that I observe. So if I put a rat in a cage and I make the environment very simple and I make the rat hungry and I give it a lever that he has to press to get rewards, I can precisely describe you that rat's behavior. And, and I can, with mathematical precision, and there's nothing I need to infer about their mental processes and so on. So the problem is that curiosity is precisely at the intersection of these fields. So curiosity is what falls through the cracks, because curiosity is the desire to know. Or the desire to learn, or the desire to ask questions. So it's a desire, right? It's a motivated behavior. I decide that knowing X or Y is useful for me than knowing A or B. I make a decision. But a decision is about a mental process, is about information. So I don't make a decision, that I want 2 bananas or 2 drops of juice. I make a decision about what I want to think about. So it requires, to describe curiosity, you have to describe both how we think and what we think, and also how we assign value to those thoughts and that information. And that is just, outlandish. It sounds an outlandish question to ask. And this is in my lifetime, 10 years ago, when I started asking this question. People were looking at me like my colleagues would say, "What do you mean?" So I don't know. Why are you even asking this question? Okay. But it is the question to ask. I think it's the unavoidable question to ask, because what happened is we have these two streams of research. We have cognitivists, behaviorists. They develop their own tools, and they're really quite sophisticated, each one of them. But at least in my case, it almost feels like we've reached the end of the road. We need to get out of our bubbles, and the next step is to connect those two bubbles. So my research so far is fairly reductionistic. I mean, it stayed at the fairly low level, and I think most research and like I said, the field in cognitive science is just beginning. So I know that all the studies we do are at this very low level. Curiosity has been studied in personality psychology and social scientists, and they talk about personality. They have personality questionnaires. Are you a more curious person in general, like a trait, or more curious, and how that relates to various things and various life outcomes and so on. Curiosity is also important for clinical therapies, that the therapists know that they have to get you to be curious. It's a way of relieving anxiety and getting you to step back from a situation and so on. So people are familiar with the emotional. I think at that level, people talk about the emotional aspects of curiosity. But we at the level of the brain, we haven't yet grappled with that. And actually that's something I really look forward to in the next few years, to start looking more into like the real curiosity with capital C.
Just because I guess you study in animals also. So studying the idea of curiosity in animals and that capital C curiosity, what would that look like?
The first thing that you notice is an animal looking at you. Right?
Yeah.
Right? Especially, yeah.
Curious rat. That sounds really fascinating.
I mean, the rats, they sniff their environments. They, clearly that they do active sensing. So if you just look at curiosity with capital C, well, that's it. They want to know what's this, what's that, what's that.
You've done a number of research studies on curiosity. Is there one maybe you'd like to mention?
My particular entry into this topic was through an interest in attention, and particularly eye movements. What I learned about eye movements are the sensory motor pathways. So how you get in the brain from, let's say you have a flash of light on your eye, on your retina, then how that gets transformed, and eventually it makes a connection with the muscles that move the eye to the light. But that was pretty much figured out. That's what I studied in grad school, and I thought, okay, we figured that out. So the next step is the cognitive dimension of it. So in most cases, we're not put in a black room with one light, that tells you where to look, that light. Most cases, we have a million things, especially today. But it really always, we've evolved in a very complicated world in which things are not pop out to you, or the things that pop out are not the most relevant behaviorally to you. And we have to navigate that world, and we do navigate that world. So the brain makes some very complex decisions about what is important, which of these signals that are important at every point in time, and so on. And I wanted to understand that decision. So, and it turned out that decision, how do you decide where to look? It's almost the same question as what are you interested in, or what are you curious about, right? Which information do you want to get? So then I started thinking in a theoretical way. So let's say I am a mathematician and I have different sources of information, and how should I select between them? And it turns out that in decision theories, there is a very good answer to this question. So you have to think about probabilistic reasoning. So in decision theory, information is defined in terms of uncertainty, and it's the reduction of uncertainty. And uncertainty is a probability distribution. You think of it as a probability distribution. So for example, you can ask, will it rain today? So you might have some prior guess about that. Well, I kind of think it's 50-50 likely to rain. So that's a probability distribution. You have an outcome, rain or no rain. Each outcome has a probability, and that's a distribution. And if you're 50-50, that means that's a high uncertainty. So the way distributions work, if the options have kind of equal probabilities, that means you're very uncertain. You don't know which one is more likely. So let's say you have uncertainty about whether it will rain. And then you have in your mind sources of information. So, should I ask my husband? Who should I want to reduce that uncertainty. I want to know rain or no rain. Should I ask my husband? I don't know. Maybe he's stayed home all day. Should I, look at the walls? Well, probably that's not very informative. Oh, should I look maybe at the forecast? Okay, that's a source of information that I can expect to reduce my uncertainty. And then, so I don't know if the forecast will tell me rain or not rain, but I know that on average, after I look at the forecast, I will have less uncertainty than before. So there's a whole mathematical theory that quantifies how to measure uncertainty, how to select sources based on their reliability, and then how to update your predictions based on what you see in the source. So if I try, it turns out that if I tried to program a computer under certain very simple conditions, if all these probabilities are known, it would be like a really trivially easy task to solve. But of course, in real life, it's much more complicated because the probabilities are not clear. The probabilities that are, and also combining things in this perfect way or mathematically correct way, it turns out is not intuitive for people all the time. But when I started, I had to take a step back and say, okay, so this mathematical theory tells me I should pay attention to how much uncertainty I have. I should also pay attention to how reliable my sources are. And I think that all of these should be somewhere encoded in the system of attention because I have to use these quantities to know where to pay attention. And we had no idea whether that's the case. And so I think probably some of my most important experiments have to do with neural recordings, where I recorded in structures that are involved in selecting targets for eye movement. So they tell you, look to the right, look to the left. And I show that these signals of uncertainty and also of reliability of sources of information are present in those areas.
So eye movement shows uncertainty.
Let's say you're making a decision or you're solving a task. Right. Sometimes you might know what the correct answer is. Let's say I have to press button on the right or the left. Like sometimes I know ahead of time, oh, I'm going to press on the right, and that's going to be good. Then you don't really need to pay attention. You don't need to collect additional information. You can just go and press the button. Mm-hmm. But imagine that you do the same task and now you're uncertain. Is it on the right? Is it on the left? Mm-hmm. Now, if you don't know, you don't want to guess. If you just guess, you have only 50% chance of getting the reward. Let's say you want to do a little better. Well, I might look at something or I might pay attention, get a bit of information, and that bit might tell me, well, it's 80% to the right, so go right. Right? So this is how we're showing that if you have uncertainty, it turns out that your attentional system, you have like literally your pupil highlights, that there's like a mini burst of arousal that allows you to engage your attention and process information a little better. Then you'll find out the answer, and then and then if you have lower uncertainty, you can actually, the arousal level decreases and you just go in sort of habit, autopilot mode.
Curiosity is something that you are very interested in now. Is there something else that you find more fascinating at the moment that you're looking into, or is that your thing?
No, I mean, I think there's nothing more fascinating. Yeah. because curiosity is such a huge concept. And like you said, it sounds very different. Like if I think of it in terms of an eye movement, that sounds like one thing. But if I think of it in terms of asking a question, that as a student in school, that's yet another thing. But I am fascinated by the fact that all of these have a very similar purpose, which is to direct us to information in a very selective way.
What do you think is the future of curiosity research?
It has a great future. This whole field, there are people who study so-called epistemic emotions, surprise or suspense or laughter or mirth, like amusement. All of those have to do with what we know, how surprised we are, what we expected, how this expectations are violated, and sometimes it's good and sometimes it's bad, right? So there's a positive valence and negative valence. All of those emotions are so little understood, especially at the neural mechanism. Another area of progress will be with artificial intelligence. This is a question that's very at the forefront of artificial intelligence because any autonomous agent that you program, self-driving car, they need to be able to selectively process information. They need an attentional system. That's the big thing that they're missing. Cars, they don't know what to pay attention. They're easily confused by too much information. How do you do that? And so you have to signal, again, where there is uncertainty. And it's really interesting that mathematically they use the same formulas, but The question is, how do you build it into the system? How do you propagate uncertainty? How does the car know now I'm more confident, now I'm less about this and that, right?
Or AI system can be programmed to have curiosity.
They should first be programmed to answer questions, to have an attentional system. So,
Right.
so in other words, I'm a car and I'm not, I play by the rules of a car. But within being a car, I need to ask particular questions. Now, curiosity would be an agent that says, well, I started off as a car, but I can go on and investigate other things and teach myself how to be a basketball player. And that's becoming a bit more concerning. I mean, I think that we might be able to get there, and then that will start causing a lot of questions.
That's, really interesting from a neuroscientific perspective. That's the key area that takes it from being manageable to possibly dangerous, I guess. Correct?
Yes, because if you give an agent, so much agency that it can decide what it wants to learn, you have to start putting a value system in it. And it's interesting, we are very powerful humans as opposed to other animals. We do have more capacity for learning, but we also have a moral system. And I wonder, and I think these two are very closely related, because without a sense of morals and values, we can learn all kinds. I mean, we could take things to their logical conclusion. Well, there's climate change. Well, let's just kill all the people. We'll get rid of climate change. I mean, that's reasonable. You could call it rational. So we need to have a moral system in place, a value system in place. So the same thing would be with if we manage to have an autonomous learner, artificial learner, we have to give it a value system.
How can that be affecting the way that people act, consider things, or consider curiosity? Or can they gain some benefit from the research that you're doing? Or can you take some conclusions to offer, let's say, individuals of what they can learn from your research?
There are a lot of things that we take for granted. So, for example, what we pay attention to, that's one thing. A lot of the ways in which we process information is hidden from us. And also the ways that we attend to are hidden from us. So what we see, when I look out, I see something. I see a street with a red car on it. Mm-hmm. Okay. And to me, that's reality. It's not, I don't have the subjective sense that I did something for it. The street is just there. That's what was there. Mm-hmm. But in fact, a lot of it is subjective. What happened is that you looked out on the street, you notice your brain noticed the red car, and it ignored 10 people who were there, maybe. And you have no idea that your brain did that. You always see is that, well, there were no 10 people there. I didn't see them, right? Okay. But that is plastic. But your brain made that decision. So we have to remind ourselves that our brains make those decisions, but they can also be trained to make other decisions. So we often can look at something or somebody and say, well, that's what they are. But we should always remember that there are things we didn't notice. There will be things. There always are things. So we should take that as a default.
It was so wonderful to talk to you, Dr. Gottlieb.
Curious by Nature is a production of Newswise. More than 7,000 journalists get the Newswise wires. Visit newswise.com and find out how to spread your news today.